Hey there, I'm Zen, and today I will be teaching you how you can make your own AI smarter and more accurate by including your own data. Now, before we get started, I want to emphasize that it's really important that you watch this video from beginning to end, because I won't just be explaining to you how you can call APIs, I will actually explain some theoretical concepts that are really important as you develop any kind of AI solution. So with that being said, let's get started. On the left here, you can see a small code base. The repository is actually publicly available and linked in the description below, but I'll walk you through roughly what the script does. Really what the script does is it calls the GPT-4 model via the OpenAI API with a simple standard system prompt. Later on, we will actually enrich this AI assistant with my own diary data. But before we do that, let's ask the AI model a simple question. What are you? So in this case, you can see that the AI responds simply by saying that it's an assistant designed to help answer questions. Pretty simple, right? Now let's ask it a more personal question. So I want to ask it the question, what did I eat on the 8th of June, 2023? In this case, of course, the assistant doesn't really have a way to know this. And it also tells me that, right? So the AI doesn't have access to personal data about individuals at all. And this is a very important fundamental concept to understand. If your data is of poor quality or missing, then it doesn't matter if you're using a state-of-the-art language model or a smaller language model that's running locally on your device. Your output is going to be poor. You're not going to get the answer that you want. In this case, as long as I don't provide the language model with my own data, it won't be able to answer these questions. Or even worse, it might come up with an answer that's hallucinated or made up, as others might put it. So, how can we go about including our own data in these AI models? Let's have a look. Here I have my diary. This is kind of a fictional diary, of course, because my real diary is a little bit too confidential to share here. But in any case, we have a diary here that contains information about what I did on various days in 2023. And this is all in a nice markdown format. So the question really is, how can we make ChatGPT, or in this case, GPT-4, search for this information and then inject it into the prompt so that when someone asks a question about one of these diary entries, the model will always retrieve the most important bit of information and then use that to answer the question. To explain how we can inject our own data into AI, I want to create a quick diagram of what we are trying to achieve. So we always have our bit of own data here. The important part about this data is that it's always a text format. This means that you can have data which is a video or an audio file, but you will have to use some kind of model or service to translate that or transcribe that into a text format, because a language model can only really understand text, right? Now, what we could do is if we have this data, we could literally just feed it directly into the AI or large language model, right? So this is one approach. We could just directly feed it in there, right? However, the problem is that you usually have more data than the language model can feasibly understand in one go. For example, if you've collected a bunch of Wikipedia pages, then the context size is probably too large for the language model. So just doing this directly doesn't really work. This means that we need some kind of system that actually selects the most relevant bit of data and only passes that on to the large language model. So before we feed, we actually need to have some form of search, right? Search mechanism that will search through that data and find the most relevant bit of data that corresponds with the user's question, right? So this actually gets passed on to the search mechanism, which feeds most relevant docs straight into the AI system. The most important thing to realize here is that the search mechanism can be many different systems. It could be a more traditional system that relies on keyword search, but what we see used a lot in the AI space is this concept of embedding search. And I will explain to you what embedding search actually is, because it's a strategy that you want to rely on most of the time, if not all of the time, for your AI solutions. The idea of embedding search is that we first convert this text into an embedding. And an embedding is basically a numerical representation of the text. So it's basically an array that has a bunch of numbers like this as an example. And the idea behind this conversion is that the moment you have numbers, you can actually do math, right? So in this case, we have an example embedding. And what we are doing with this embedding is effectively we are able to plot this on a graph. In this case, let's just make it a 2D graph for simplification purposes. And then you will have all your little bits of data on this graph, right? So for example, we might have the diary entry A, that's somewhere on the top left, while we might have a different diary entry that's on the bottom right. And the way that these embeddings are being plotted on the graph really just depends on the context of the data. Now, actually explaining thoroughly how an embedding model works can be rather complex because I'm drawing out a 2D graph here. However, in reality, the embedding system that OpenAI provides to us is multidimensional. And when I say multidimensional, I mean that there's literally hundreds of dimensions out there, which means that you cannot even plot the way that OpenAI converts your text into a numerical representation like this. However, the point remains the same. You're able to plot out all of the different types of data that you have. And then when a user question comes in, the idea is that you use mathematics to find the closest diary entry to this user question. So for example, we might have a user question that actually touches diary entry A mostly. So in the embedding space, the question might live somewhere here, right? And if this is the case, you can see that the closest overlap is with diary A. So in this case, that diary entry could be passed down to the GPT model, while we know that diary entry B is just a bit too irrelevant to be passed onto the model. And you can imagine that there are many strategies here. You could take either the most important document or the most important 2 documents or 5 documents. It really depends on how big each of your documents is and what your AI model allows you to pass on. The point here is, though, is that we have a very structured way of searching through documentation, finding the most relevant bits of documentation, and passing that onto the large language model instead of trying to cram in literally all of your data in one go. Now, there are more advanced strategies like actually fine-tuning the model, and in that case, you do actually feed in all of the data to fine-tune a large language model. But for this video, we're really going to focus on this method of embedding search to achieve what we're trying to do here. So let's go back to the code and implement embedding search ourselves. Welcome back to the code base. Now let's go ahead and convert those diary entries into embeddings using the embedding model that OpenAI provides. You can use a different embedding model or even create your own if you have an advanced need for it, but this suffices for now. What this script does is it creates this embeddings folder with the converted embeddings for all those markdown files. And these are the numerical representations that we're looking for. Now, in this case, it's just a proof of concept, so we're just storing it in plain text files, but in a production environment, you would probably store this in a vector database. If you want to learn more about that and really know how to store these embeddings in the right way, leave a comment below and I might cover it in the next video. Now then, if we have these embeddings files, we can also actually search through these embeddings to find the most relevant bits of documentation to answer a question. If we look here, this script actually allows you to pass a use embeddings parameter value of yes or no. So we're going to be passing a yes so that it searches through all the embeddings it has, right? But before we do that, let's actually quickly talk about how it does that. Now, this uses a concept from linear algebra called cosine similarity. In this video, because it opens another can of worms, I'm not going to go into that. But again, just like with the vector database, if you would like to hear more about it and understand how it really works, leave a comment below. But for now, it suffices to know that this Python function, find most relevant entry, will look through all of the embeddings and find the most relevant piece of content for the user's question. And it's good to know, by the way, that the user's question will also be converted into an embedding so that it can actually be compared with the embeddings of the diary entries. So that being said, let's think of an interesting question to ask to GPT now that we have the embeddings of the diary entries. For example, if I look at the 8th of June 2023, Apparently, this is when I ate some chicken Alfredo pasta. Maybe it's interesting to ask GPT if it remembers what the last date was that I actually had this dish. So let's go ahead and try that. Let's go ahead and type out Python ask GPT. And I think my question will be, what was the last time I ate a chicken pasta dish? And then, of course, we're going to also pass a yes, because we want to make sure it searches through all those embeddings. All right, so a lot has happened here. So I want to give you a bit of a rundown of what's going on here line by line, right? The question has been received as, what was the last time I ate a chicken pasta dish? Now it's generating embeddings for that input text, again, because it needs to do this to be able to compare that text to the embeddings. It's loading the embeddings from the directory, and now it's comparing all of those different markdown files with the user's question. And what jumps out here is that apparently the 8th of June was the most relevant entry. This is a number that basically goes between, it might be 0 and 1 in this case, it can be -1 and 1, depends a bit on the method you're using. But in any case, the proximity of this document is quite close. It is the closest one, at least, compared to the other markdown files. And the reason behind that is really because the whole context of chicken pasta is also mentioned in this document, right? Because you see here, it says that I had a hearty bowl of chicken Alfredo pasta. So this means that the search is really good at picking up context cues and finding the most relevant bit of documentation based on the user's question. So now it found this as the most relevant entry, and it really just injects that markdown file into the system prompt. So the system message is appended with that diary entry, and because you're giving that data to GPT or your other large language model, the GPT response will tell you, and I'll move my camera around, the last time you ate a chicken pasta dish was on the 8th of June 2023 in the evening, which is a correct answer because you can see that that's actually in my diary as well. So I hope this gives you a good rundown of what it really means to inject your own data into an AI model. Now, there's a lot of caveats here. This is just a proof of concept, so not every question you ask will pick out the right document. And to be completely honest, the markdown files that we have here are so small that you can probably pass in 3 or 5 documents at once, maybe even more. But it's more about understanding the principles behind embedding search and understanding that this is a very important method within the AI space right now to retrieve documents. That being said, you can also retrieve relevant information a different way. The way that systems like Bing GPT, for example, retrieve documents is that they convert a user question into a smaller query, and then they might use that smaller query to call the Bing API, right? Or a different search provider API for that matter, if you're using a different system. And that API will return a text representation of web search results. So then again, you can simply feed that information into the language model and it will come back with a pretty accurate answer. So you can really come up with many creative ways to use your own data to make your AI smarter and more accurate. If this video helped you, make sure to drop a like, leave a comment for any details that you would like to know more about in the next video, and of course, subscribe for more.